some of the optional criteria could also be very important. As it appropriate might be very simple. How simple it is. If you have a method that has two methods that has the same level of discrimination, same level of reproducibility, same level of typability, of course you want to prefer the simpler methods. These days with technology there are some simpler methods are being developed. Okay. Sometimes depending on your study type, you may need a field deployable methods. Is that there are PCR-based methods, others that you can really essentially take to the field, or in a hospital they call it point of care, or if there is a method, you don't have much methods, but if you want to take them to slaughterhouse, collect a swab, do something and tells you fingerprints, that would be wonderful, or on the swine farm. But usually not so limited. But there are other, depending on high value pathogens, like in the U.S. Department of Defense, there are some contracts like Idaho Technology, mainly for military purposes, but really you can use for, we tried one in Africa setting in field, using the Idaho Technology thermocycler. You can essentially take it all the way to some jungle areas, and you can do a PCR from serum samples from wild animals for many pathogens, usually highly infectious pathogens. And in half an hour, it's a real-time PCR. You attach thermocycler to a small laptop. You can use power from your truck, from the car charger, and in half an hour it tells you whether there is anthrax and pestis or some other things. But for many other pathogens we use for a day-to-day basis, that may not be available, but it is possible. High throughputness, sometimes essential criteria, by the way, often not, but this is the capacity of a test to process large number of specimens. Okay, large number may not be necessarily a question, but if you are dealing with a national surveillance system, if you are establishing a new surveillance system for the nation and other things, or if you want to finish your PhD quickly, you want to you may prefer a method that has high discriminatory power, high reproducible, and gives you high throughputness. Really, when I did my PhD, I had a PFGE. Peter Davis was my advisor too. So he left to Australia, but I had a machine that we bought. I was using 12, 13 isolates. I have 500 salmonella, so it's running this. And then from a forestry group, acacia genome mapping group, I was taking a course and I learned that they use this AFLP, amplified fragment length polymorph. You can run 64 at a time. I said, if this thing works for salmonella, I better crank up my... So I ended up doing AFLP with that, and it worked nicely. Just before ours, Arts from Netherlands was using them for salmonella as well. Right after we modified it a little bit from his, use this acacia genome projects equipment, it worked. So again, it's high throughput method, but the same level of discrimination. We compared it, the discriminatory power, I compared it for my PhD between PFGE, amplified fragment length polymorphism, and rep-PCR, repetitive extragenic palindromic PCR. And for us, at least at that time, rep-PCR did the worst. Not so reproducible, lowest discriminatory power, even lower than antimicrobial phenotyping. AFLP PFG did the best. We published that in Epidemiology and Infection in I think 2005, 2006. Years after that, but it was just our goal was to compare which one gives me the best in terms of the criteria. So again, the point is high throughputness could be very important, especially if you deal with developing surveillance systems. Speed. So as I underlined here, this is absolutely important. Whether it's in human disease outbreak or an animal disease, you want to track quickly what is in the pigs, you want to launch your control measures. The speed becomes an issue. You don't just want to wait 3-4 days long genotyping method while you can do a quick and dirty way to be able to detect at the cost of discriminatory power or some reproducibility, you may choose a method with high speed sometimes. So there are many criteria, but you may reprioritize them depending on the epidemiologic setting. But if it's outbreak investigation, often how rapidly do I get the results will become a big factor in the priority order. You don't want to totally compromise and mislead you in terms of discriminatory power, but how rapidly you get becomes a big factor. Okay. The cost, it's always an issue. All the economy now, except Australia, I think everybody has been not doing well. You're selling lots of coal, and but cost is always an issue. So in your lab setting, but that's optional criteria to consider. Okay. So just to wrap up the criteria. So your consideration of the criteria, the priority you want to use depends on so many factors. Number one, what is the epidemiologic scenario? Are you dealing with outbreak? Is it just for research purpose? Even the magnitude of the outbreak. The research purpose, are you establishing surveillance system? What are the logistic capabilities within your reach? Can I really afford doing next generation sequencing or other? The sample size, is it a very large sample size you're dealing with, a smaller? Quick outbreak, with 5 pigs, others, it is different choice, different criteria, versus you have a large area, swine production system, you establish a surveillance. It's a totally different thing. So the priority of the criteria also depends on that, therefore the choice of genotyping method could also be affected. So there is no one size fits all way. Even if you deal with salmonella in pigs, it doesn't mean that you have to always use one method. It can depend. You have more choice of method. So based on these situations, the epidemiological scenario, sample size, and others, you can reprioritize this criteria and select the right genotyping method. Okay? Does that make sense?